Okay, so welcome back to C# application development. So what we're going to do right now is go through some really general kind of just syntax basics, just kind of the bare minimum basics. We're going to go through these really quickly, and then we're going to move over to some slightly more advanced stuff, particularly around encapsulation. And then we're going to cap the first unit off with a code along that will kind of rehash all of this stuff and kind of put it into practice. This video is really going through some slides. Those slides are probably most helpful on their own as a kind of just really quick resource, like reference guide. But I did want to talk through some of them in case there are some kind of nuances that need to be discussed. So the very first thing in C# is that variables work exactly the way that you would expect a variable to work in a high-level language. So you have the name, the type, and the value of the variable. These are some examples. It works exactly like you would expect from C++ or Java. It kind of just follows what you would expect. The naming conventions around variables in C# are kind of similar to what you might expect from Java or from C++. These names are largely called identifiers. That's true of most languages. It's kind of a software engineering concept. And bad names for variables or bad identifiers are often called lexicon bad smells. And these things can cause a lot of damage over time. They're a very large component of technical debt that you might rack up if you were trying to sort of generate a very large program. You had particularly bad identifier names that can lead to other people trying to maintain your code and not being able to do so simply because you named things weirdly. So in C# particularly, almost all identifiers are camel case, but local variables often appear with a leading lowercase letter. So you kind of know that a variable is local simply because it begins with a lowercase letter. Private fields, which we'll discuss in a little bit, are also camel case with a leading lowercase letter, but in a lot of organizations, they make the decision to lead a private backing field with an underscore. But really, there's very little difference between a local variable in a method and a private field that is material in your investigation of a method. This kind of doesn't add a whole lot, and it in some cases makes searching through the code a little bit more cumbersome. So in a lot of organizations, they name local variables and private fields effectively the same convention. In any event, public properties are almost exclusively camel case with a leading uppercase letter. This allows you to very quickly be able to understand the visibility of the property, and it also helps you distinguish between things that are associated with the class that you're working on and just a local kind of method variable that isn't associated with that class. One interesting thing about C# is it supports what's called the var keyword. This thing allows you to use an implicit type system that's inside of C#. And what that does is it allows you to specify a variable, and as long as it's initialized at declaration time, you can use the var keyword, and the type of that variable will be inferred from the right-hand side. And so here you can see that first number is going to be an integer because the right-hand side of the assignment is an integer. Some string is going to be a string because the right-hand side of the assignment is a string. And so in a lot of cases, the var keyword is considered to be a best practice because a human can infer what the variable type is even quicker than the type system can. So it keeps code much cleaner in order to just use that one keyword instead of whatever variable type you're explicitly declaring. So one of the things that we're going to mention several times in this first unit is that everything in C# is object-oriented. So even if you have a console application and that console application is something as simple as our Hello World example from the walkthrough videos, that is a class that has a single static method, much like Java is. Classes themselves can have either fields or properties, and basically both of these things do exactly the same thing. They provide access to class level data. So fields and properties both act as state for the class, and really the differentiator between them is the code that you can run on properties versus no code being run on fields. So fields are effectively just variables, variable members of a class, while properties allow you to specify getter and setter business logic that run before either you receive or you set the value of the backing field. So fields provide just sort of raw data access without business logic. These things can be public, they can be private, they can be internal, and they provide just basic access to the data. So these things are functionally equivalent to a variable, except they might be associated with either a type if it's a static, or an instance of the class or an object if it's non-static. So properties provide access to a field, often a private backing field, but they also run business logic that effectively implements some sort of data integrity requirements or something like that prior to setting or receiving the value in the private backing field. So you can think about these as things like with a name field, you could have access to the field be through the property, and the property could enforce that all names begin with a capital letter, something like that. If you opened up access to only the field, a person would be able to put whatever they want to in a string value or a variable. If you specify access only through the getter and setter property, then you will be able to specify that it doesn't matter what the user tries to set the variable to, the first character is always going to be an uppercase letter. So this is an implementation of exactly that. So we have a private string, student name, lowercase s at the beginning. This thing is often called a private backing field. It is a field because it is just a variable that exists off of a class somewhere. The property is a public string variable, has the uppercase s at the beginning, but it also specifies getter and setter logic. And so here the getter is returning the first name, but it is making sure to cast the first character to uppercase before returning that value to the caller. The setter, likewise, is going to set the student name to whatever value is passed, but it is going to capitalize that first value first, or the first character first. So the real question around properties is, why do these things exist? So basically what you want to do is you want to use properties anytime an external class has access to a property on the class that you were actually working with. The reason is because you want to maintain the integrity of the state of your class within the class. You don't necessarily want to have external classes have free reign over whatever data they're passing as state to your class. This is a very easy way to enforce data requirements. Even before you start talking about things like databases, you can very easily enforce the fact that names have to begin with a capital letter or something like that. So much easier are things like conditionals. Conditionals, loops, all these kinds of things will look very, very, very similar to things that you've seen in Python even, or Java or C++. Here we have an if-else conditional. We use the syntax if, else, and you can nest as many else-if conditions as you want. Each of these things are mutually exclusive. So if you fall into one of the cases, none of the other cases will be triggered. You could, of course, have sequential if statements that are not mutually exclusive, and then multiple if statements could get triggered by a condition. There's also a ternary operator inside of C#, and so here we have a condition, first number is greater than second number. If that condition is true, the first bit here will be triggered. If it is false, the second part will be triggered. Ultimately, you can trigger multiple ternaries and string them all together. So the ternary operator here is the question mark, and the first part that gets fired if the conditional is true is before the colon. The part that fires if the condition is not met is after the colon. And here what we've done is we've stuck two different ternary operators together, nesting the second one inside of the first one's false condition. You also have the switch. So switches work exactly the same way that switches work in all of the other languages you might be familiar with. Each case has an enumerable associated with it. So here we have an integer called first number. If first number is set to 1, as it is here, we will fall into this case and then break out. If it is set to 2, we will go here and then we'll break out. If it is set to 3 or 4 or 5 or some negative number, we will go into the default case and we'll break out and we'll go on to whatever statement is next. C# also supports what's called fall-through switches. So here what will happen is if the first number is 1, it will go into this case. It will see that there is no break associated with case 1 and will fall into case 2 before hitting case 2's break. So here we have printed out first number is 1 or 2, which corresponds to the fact that either first number equals 1 or first number equals 2 would print this same right line statement. And the reason is that case 1 does not have a break associated with it. So if you have multiple cases that do the exact same thing, all you have to do is not have the break in any of the first cases, and they can just fall through to whatever the next case is. So arrays and lists in C#, that's something that this is a specific reason why I wanted to have a video associated with this set of lecture slides. Arrays are exactly what you would expect arrays to be from even C or C++. There are helper methods that help you do things like allocate and reallocate sizes of arrays. However, under the covers, they work exactly the same way as you would expect an array to work from any of the other languages that we often teach in the department. Lists, however, are much more dynamic. They are much closer to a vector in C++. You have array lists and collections in Java. They work very similarly. The thing about lists in C# is that there is a noticeable performance difference when you are working on array lists versus arrays. And so colloquially, many people recommend using arrays when high performance is required. However, if you're working on a C# application, it's often the case that just sort of face melting speed is not the thing that you're optimizing for, and usability and easier management of data is a completely fine thing to get in a trade-off for speed. So in a lot of cases, you're going to want to use lists just for ease of use. and that's entirely fine. C# is not known to be blazing fast anyway. It's certainly faster than Python, and the difference between lists and array data types are not going to actually impact the performance that much, as long as you're kind of watching what you're doing. So here, this is an implementation of a list using both an array of numbers and a list type of numbers. And obviously for the list of numbers, we can simply just add 4 to the end. If we wanted to add 4 to the end of the array, we would have to create a new array of size 4 and then copy the 3 values that we have to the beginning of that array and then append our new number to the end. Note that var still works here, so var will detect the fact that the right-hand side here is either a new array or a new list of type int, and it will be able to do exactly the same sort of things as our explicitly typed array and list of type int is doing before. So talking about loops, loops are, again, largely the exact same. So the while loop here does exactly the same thing that the while loop does in Java, does exactly the same thing that the while loop does in C++. There's nothing really to see here. Do while is, again, exactly the same. Even syntactically is the same as those other 2 languages. The for loop, again, exactly the same. For loop basically just allows you to specify an enumerator inside of the for condition. It works exactly the same way. For each, however, is a little bit of a new thing. So C# has the concept of enumerable types, and lists and arrays are both enumerable inside of the language specification. And what is happening here is we are going over the list of my list of numbers, and for each of those we are storing the value into the variable num. So you might have seen the Java syntax for and then a type and then a colon and then a list. This is exactly the same as that syntax. It's the same concept. What C# is doing here, though, or what this syntax is doing, is it's using .toList on a data type or a variable that is already a list, and what it's doing is making an internal copy so that we can actually remove a number from our original list of numbers without causing a crash. And the reason that we need to do this is because of what's called a loop closure. So we'll talk about that in just a second. There is quite a bit of performance sort of chatter and debate around if you should be using for loops versus for each loops, if you should be using arrays versus list types. This is a thing that I'm actually currently working on a paper about. It's to that level of empiricism. And there are some people who feel religiously that you should not use list types because of their performance overhead. So this ultimately comes down to these weird edicts, like every time you call .toList on an array, or even worse, toList on a list, an angel loses its wings, etc., etc., etc. Basically, what you need to be aware of is that there is probably some overhead anytime you're using a data type that does stuff that you perceive to be for free. So by virtue of using the list data type that allows you to resize the list, you have to pay some penalty in performance in order to gain that ability. So the trade-offs around wanting to be able to understand your code versus the millisecond increase or decrease that you could get by using either a list or an array respectively is probably completely understandable, but one of the things that you need to do as you're creating any piece of software with any sort of language is you need to be cognizant of what you're trying to achieve. If you're trying to build the world's fastest algorithm at sorting. Potentially you want to go all the way down to the brass tacks, and you want to be very cognizant of the data types and the loops that you're using in order to do that search. If you are building a point of sale system for a fast food restaurant, they probably do not care about the 40 to 55 millisecond difference between your implementation of a collection. So you have to be kind of mindful, and in some cases it's good to even have maybe unit tests or some sort of other empirical test to determine the impact of using specific data types or specific loop types for whatever sort of job you're trying to accomplish. But in general, comprehension in a C# application is almost always going to win out over performance. And if performance really was what you were looking for, you would be using something closer to C than C#. So going back to our previous example, we had this kind of hilarious thing where we're calling toList on a variable that leads us to believe that it's already a list. And so the obvious question is, why the heck are we doing that? So for each loops, work on what is called an enumerable. And so what's happening is we are going through that list piece by piece, and we are taking each element at the next index, and we are storing that into the variable that we have defined in the parameters of the loop. So here we've got this temporary variable called num, and for each subsequent part or subsequent element of my list of numbers, we're going to take that element and stick it into this temporary variable. The problem is when you change that list while you're trying to run the loop. So going back here, we are actually removing num from my list of numbers. And if we weren't going over a copy of my list of numbers, we would actually potentially get into an infinite loop, or we would run over the bounds of the list, depending on what kind of math we're doing in here to remove numbers. So we do this .toList to actually make a copy of my list of numbers so that we don't run into weird situations where we are removing or somehow modifying the list as we're trying to enumerate over the list. That is what closure in this context means. It means that you should not be modifying the list that you're using to enumerate through the loop. So typically this is not a great thing to do. So what you want to do is make sure that if you have a scenario where you're trying to add or you're trying to remove elements from a list, you should not use for each loops. You should use a for loop, or you should use a while loop. You should use some loop that will allow you to index the loop outside of the purview of the loop. Or index the list outside the purview of the loop. So if you have a for loop, you can set the index to be whatever you want. You can manage the list outside of actually iterating over that index variable. So we will see quite a number of cases in the class that we really want to use for eaches because they are very easy to read, they're very easy to understand, even if a different person comes and reads your code a year and a half later. But in some cases, you don't necessarily want to use them. You want to use something like a traditional for loop, and this is the first kind of concrete place where you want to do that. You want to be sure that you're not using for each loops when you're trying to modify the list while you're looping through the list. It kind of makes sense. So that kind of wraps up the basic kind of rudimentary syntax. It's kind of a remedial look at computer science, to be honest. And I don't want to spend a whole bunch of time on it because the previous iteration of the course, those guys indicated that they became extremely bored with the content. So thank you for making it this far in the video. Next, we're going to talk about encapsulation, so a little bit of object orientation before we go into the code along. So stay tuned, and hopefully we'll start putting all of this stuff together pretty quickly. Thanks again.